All right, what we're going to do today is we're going to talk about some conic sections, and specifically we're going to talk about the ellipse today. And we're going to go through how to find the standard form of the equation of an ellipse. So as you can see right here, I think my little highlighter, standard form of the equation of an ellipse. And you can see I have this written down, so if you want to write this down, this is all the major properties that ellipse has. Okay, these are found in all major textbooks and whatnot that deal with pre-calculus stuff. But the key thing when we're doing this is that there is mathematical and there is, well, obviously it's all mathematical. There are equations that you can do to figure all these different things out. However, what I like to do is I really like to graph these different parts. So what we're going to do is we're going to go through a couple examples, give them some different criteria on how to find the standard form of the equation. Let's give them some different criteria. So without further ado, the first thing we want to do is we are given in this one a minor axis of 2, 0, and 2, negative 2. So what we're going to do is we're going to graph this. I'm going to graph this. Okay, I'm going to try to make this a little bit bigger because it's going to be relatively small. So we have 2, 0. So 1, 2. Here's 2, 0. We'll graph that. And then we have 2, negative 2. So we have 2 and then negative 2. Oops, probably should move that down a little bit more. Right there we go. All right, and there, right here, is on our minor axis. Now, this is key thing, is that we're going to identify the minor and major axis. When you're finding an equation of ellipse or any ellipse, our key strategy and what we need to find is we need to find the center and the A and B values. To do that, what we're going to do is a bunch of different things can help us find our center. The other thing is we can identify our A and B values by figuring out the major and minor axes. Remember, the A value in all these values, all right, is under the variable with its corresponding major axis. So in this case, we have a minor axis. And when we write this, we can see that this minor axis goes vertically. So that means that since we have a vertical minor axis, our B value, which is associated with the minor, okay, is going to be underneath the Y value because the Y is the vertical variable. Our major axis, when we write this out, and we'll finish this up, we have 0, negative 1. Okay, so 0, negative 1. Going from here, and then we go from 4, 2, 3, 4, negative 1 right here. And we can graph this, and we can see this is the major because it is the longest of all the axes. And I'm not a very good drawer, and my obviously my scales are way off. I apologize, but that's just the way it is. All right, now from here, what we're going to do is we're going to figure out the center. Now, the center is the midpoint between the major and minor axes, or the vertices on the minor axis and the vertices on the major axis. And what we can see is where they intersect, this point is known as the center. And so if we take the midpoint of these 2 points, we realize that we're going to have 2. There's going to be an x value. So when we write this out using this as our standard equation, we're going to have x minus 2, because it's going moving 2 to the right, squared. Then we're going to have our y value. And we can see right here our y value is going to be negative 1. So it'll be y plus 1, that quantity squared. I'm running out of room, so I'll just put that over here. And I will erase this right here. Okay, and that, we have that. Okay, and there we go. Okay, from here, we're going to now take this, and now we're going to find our A values. This, remember, set equal to 1. All right, and now our A value. Now our A value, if you recall, is the distance from the center to the vertices on the major axis. So this length from the center to the vertices is our A. This A value is the same on both sides. So you can see that this distance is going to be 1, 2, 1, 2, so A equals 2. Because it's a horizontal axis, it's under the x, so we're going to have 2 squared because A equals 2. And it's under the x because it's a horizontal axis, major axis. We can then look at our minor, and the B value is on the minor, goes from the center to the minor point up on a parabola. Not a parabola, sorry, ellipse. And we have B, in this case, is going to equal 1. I take 1 squared. And so with this, we can figure out, I'm going to take that, and I'm going to just move it. All this information down here. All right. there, and then right there, and then right here, is what we have then, is we can simplify it, and this is the equation of this ellipse. X minus 2, the quantity squared, divided by 4, plus y plus 1, that quantity squared, divided by 1 squared, which is 1, and that equals 1. That is a standard form of this ellipse. And if you want to draw it, I'm a horrible drawer, and obviously it's not in the scale, so that would be the ellipse. Okay? So that is a first example. We're going to have several others, so if you want to look at the following tutorials on 3 more examples on how to find the standard equation of ellipse.